Dear students, I am R.Mareeswari from Department of Mathematics. Now I will discuss about the curvature of a curve. Already I have studied in standard level curve. What is the curve? Bending of the line is called the curvature of the curve. The curvature means the rate of change of the direction with along with respect to along the directions. Okay. Now discuss about the curvature of a curve. The rate of change of bending of the curve in the given interval is called the curvature of the curve. What is the given any interval? How do you find the curvature? Is first find the rate of change of bending of the curve in the given interval is called the curvature of the curve. First point, the curvature of a straight line is 0. Here the straight line means having the bending of the curve. Therefore, the curvature of a straight line is always 0. And then the curvature of a point is infinitive. Draw a curve, infinitive times bending on this curve. Therefore, that is called the curvature of a point is infinitive. These two points are very important in curvature of the curve. In Cartesian coordinates, how do you find the curvature of the curve using one formula? Rho equal to 1 plus y1 square over 3 by 2 divided by y2. By using this formula, to easily to find the radius of curvature of the curve. In Cartesian coordinates, the formula for radius of curvature, rho equal to 1 plus y1 square over 3 by 2 divided by y2. The curvature means the rate of change of the bending of the curve given any interval is called the curvature of the curve. The two conditions are very important. The curvature of the straight line is 0 and the curvature of the point is infinity. Okay. By using this formula to find the radius of curvature. Let's one example. Find the radius of curvature of y equal to e power x at 0, 1. Given the curve y equal to e power x. Given any curve y equal to e power x. Point, given point 0, 1. Find the radius of curvature. Already you know the formula, rho equal to 1 plus y1 square over 3 by 2 by y2. First you have to find y1 and then y2. Substitute this partition formula, we get the radius of curvature. Okay. Here write the solution given y equal to e power x and the point 0, 1. Already given y equal to. Now to find y1. y1 means differentiating with respect to x. y1 or dy by dx. To find y1 or dy by dx. dy by dx means differentiating with respect to x. Given y e power x. dy by dx differentiating with respect to x. Given e power x. e power x how many times differentiating? We get e power x also. Here dy by dx is equal to e power x. Given the point 0, 1. Here now substitute y1 0, 1. That is equal to now substitute here 0, 1. Take this point as x. This one is y. Now substitute here e power x. Only extra. Having the extra only. Now substitute x equal to 0. Here e power 0. Anything over 0 equal to 1. Therefore y1 equal to 1. Or dy by dx equal to 1. Next we have to find y2. How do we find y2? D squared y by dx squared. Again with respect to x. Already we have to find y1 dy by dx equal to e power x. Now again differentiating with respect to x. D squared y by dx squared. Here also e power x. How many times differentiate with respect to x? In e power x, we get e power x. So, d square by dx square equal to e power x. Given the point 0, 1. Now, substitute the point y2 0, 1 equal to e power 0 equal to 1. Then y2 equal to 1. y1 and y2 also value is 1. Now, substituting the point in rho. Here rho equal to, already know the formula, rho equal to 1 plus y1 value is 1. 1 square 1, 4 power 3 by 2, divided by y2 also 1. Now adding these two, 2 power 3 by 2 divided by 1. that is equal to 2 power 3 by 2 is the last answer, but this can be written as, is given the simplification, to find the simplification 2 into root 2. Here rho equal to 2 into root 2. The lattice of curvature of the curve y equal to e power x and the point 0, 1 is rho equal to 2 into root 2. Final solution.